What if you have a face-centered cubic? Well, what you need to do now is you can say this, there's 1, 2, 3 across the face, right? 3 atoms touching each other across the diagonal of a face. So that 4R must be equal to square root of 2 times A. Okay, so for the diagonal of a face, this is A, that's A, so this must be square root of 2A. So that means R is equal to 4R. The length of the diagonal of a face is equal to square root of 2 times A. So you can say that A is equal to 4R over square root of 2. Okay? And how many particles are in your face-centered cubic? 4. Half of the 6 face particles would be 3 plus 1/8 of the 8 corner particles would be 1. 3 plus 4. So your packing efficiency is going to be equal to what? 4 times the volume of a sphere, which is 4/3 pi r cubed. Okay? And then your volume of a cube is 4R over square root of 2 cubed. And you should be able to show that this comes out to how many percent? 74.5%. Okay, so this is a much tighter packing of the particles within your unit cell. Okay, let's look at an example here. The unit cell for copper metal is face-centered cubic. Okay, so how many particles per unit cell? Face-centered cubic? 4. Okay. The density is given you can find this experimentally to be 8.92 grams per mil. So that's 8.92 grams per cubic centimeter. Figure out the length of one side of a unit cell of copper and then calculate the radius of a copper atom. So how are we going to do this? Let's assume you have a mole of atoms. What's the mass of 1 mole of copper? Molar mass of copper, you look it up. 63.5 55 grams. Okay. What would be the volume of a mole of copper then? The density is 8.92 grams per mil. So the volume is mass over density, right? So 63.55 grams divided by 8.92 grams per mil. That would be how much? 7.12 mils. Okay. So that's 7. See. What was it? 7.124 mils. I'm gonna put an extra sig fig there, an extra digit past the last sig fig there. So 7.124 milliliters. Okay. So this is 7.124 milliliters. Keeping in mind I only have 3 sig figs. Since there are 4 atoms in each unit cell, how many unit cells would you have? You have a mole of atoms. Okay. Every unit cell will be able to hold 4 of those atoms. So how many unit cells would you have total? Okay, you've got 16 people. Each bedroom can accommodate 4 people. How many bedrooms do you have? So how did you get 4? 16 divided by 4. So how many atoms do we have? Avogadro number, right? Divided by 4. Why 4? That's a face-centered cubic, okay? Face-centered cubic, you can put 4 atoms in a cell. So that's going to be 6.022 times 10 to the 23rd divided by 4. That's the number of cells that you have. Okay? So what's the volume of a unit cell? You have the total volume. You have the number of unit cells. You just divide the number of cells by, I don't know, you divide the total volume by the number of unit cells. That gives you the volume per cell. So what's the total volume? 7.124 milliliters divided by the number of unit cells, which is 6.022 times 10 to the 23rd over 4 cells, right? So that's a volume of each unit cell. What would that be? Seven 7.124 divided by 6.022 times 4. It's 4.7 times 10 to the negative 23. Let me try that again. 7.124 milliliters divided by 6.02 times 10 to the 23rd. Let's make it this way. Times 4. So 4.73 times 10 to the negative third. 4.734. 3 sig figs times 10 to the negative 23rd milliliter. What's a milliliter? That's a cubic centimeter, right? So if that is the volume of your cubic cell, your unit cell, that's 4.734 times 10 to the negative 23rd cubic centimeter. How is that related to the length of the side of the cube? What's the volume of a cube if the length of the side is A? That's just A cubed, right? So how long is the length of the side? How long is the side of your cube? A would be equal to cube root of 4.734 times 10 to the negative 23rd cubic centimeters. And that would be equal to, let's see, raised to the power cube root. So here, I just take the cube root. That's 3.62617 times 10 to the negative 8. 3 sig figs centimeters. Okay? Is that what we got? Oh, I don't have that answer up there, but I have the final answer is 127.8 picometers is the radius. Okay, so that's the length of the side of a cube. What's the radius? Face-centered cubic, you remember? That's across there, that's 4 times the radius, right? 4 times the radius is equal to square root of 2a. Correct? Remember? Face-centered cubic. 4 times the radius is square root of 2a. It's face diagonal. So 4r is square root of 2a. So what's our radius? Square root of 2a over 4. Okay. Square root of 2 over 4 times 3.617 times 10 to the negative 8 centimeters. That gives you, okay, let's see. Okay, so we have our centimeters times square root of 2 times 2. That's odd. There's no square root symbol here. Raised to the power 2. That's square root of 2. Raised to the power 1/2. Divided by 4. 1.27 okay, or 1.28, 3 sig figs now, times 10 to the negative 8 centimeters. Okay? Yeah. So what would that be in picometers? That's 1.28 times 10 to the negative 8. Centi means what? 10 to the negative 2. All right? So that's going to be 1.28 times 10 to the negative 10 meters. Okay? And 10 to the negative 10 meters is called an angstrom. Okay? So this is 10 to the negative 10 meters. So that's 1.28 angstroms. Typically, when you're solving problems like this, typical interatomic distances in atoms would be anywhere between 1 to 2 angstroms. Okay, so if you're getting a number that's way off from that, 1 to 2 angstroms, that's telling you you probably made a mistake somewhere. Okay, so it's a good thing to remember, especially if you're taking a multiple choice test. Okay, so but you should be getting somewhere close to between anywhere 1 to 2 angstroms, typical distance between atoms in a solid. Okay, now what is that in picometers? That's 1.28 times 10 to the negative 10 meters. So how do I change meters to picometers? 1 picometer is 10 to the negative 12 meters. So to go from angstroms to picometers, effectively you just multiply by 100. That's 128 picometers. Okay, so that would be the radius of your copper atom. Okay, 127.8.